Good morning, everyone. I am MalaChaturvedi, Assistant Professor of Babu Banarsi Das University. And I taught a subject, Theory of Automata in Formal Language, and today's topic is More and Mere Machine. First of all, we start the topic More and Mere Machine. Firstly, we know that what is finite state machine. A finite state machine is a machine that has many states and has a logical way of changing from one state to another state under transition function or under a guiding rules. If we discuss about the finite state machine, it has two types: a machine which is with output machine and without output machine. And with output machine, which is called Moore machine and Mere machine, and without output machine is a deterministic finite automata and non-deterministic finite automata. Now, with output machine has 6 tuples. Which is all included and same as a without output machine, but the difference is with output machine included two new functions. One is delta, which is used in output alphabets, and sigma, which is used in output function and which maps a state cross sigma gives output alphabets. So now let's start. The topic is Moore machine. Moore machine is a 6 tuple which is Q, sigma, Q naught, transition function, delta, and lambda. A Moore machine, the value of output function is dependent on the present state only. Means if we find out the output functions are state directly dependent on the output alphabets, whereas the 6 tuple which is described by a Q, that is finite non-empty set of states, sigma set of input alphabets, delta set of output alphabets, sigma output function which maps Q cross delta, and Q naught is the initial state, and transition function which maps Q cross sigma gives Q. Now, what is Moore machine? Moore machine is same as implemented as a Mealy machine, but a basic difference of Moore machine and Mealy machine is all about the output function. How output function maps in Moore machine and Mealy machine is differentiated in two machines. Now, a Mealy machine is also have a 6 tuples, which is Q, sigma, delta, lambda, Q naught, and transition function. But the basic difference is all about sigma, which is output function and which maps Q, which is a set of states, sigma, which is input alphabets, and gives output alphabets. Now let's see the state diagram of a Mealy machine. Now let's see the diagram of Mealy machine. A state diagram is shown. Alphabet A is an initial state because it's shown a arrow. The state which shown a arrow is an initial state, and the state which shown a double circle means a final state. But in with output machine, we don't have a final state because we input the alphabets and directly same state we give the output alphabets. Now come on the state diagram of Mealy machine. A Mealy machine, it's shown the A is an initial state which gives 0 input alphabets and goes to the next state which is B. And B have a self loop of 0 input alphabets and comes on the same state, and also B gives a input alphabet 1 and goes to the next state D. A D gives a self loop of input alphabet 0 and slash x3. What does it mean by the slash x3? It means a 0 is an input alphabet, slash x3 is an output alphabet, which is defined in a 6 tuples of delta. A delta is an output alphabet. And the lambda is an output function. How output functions maps in Mealy machine? The Q cross sigma gives delta. It means a state D cross input alphabet 0 gives x3, that is output alphabets. And same as if we find the state diagram of Mealy machine, we see that the state under the circle gives an output, means Q gives delta, means a state gives the output alphabets which shown in the circle, under the circle. Now let's see the Mealy machine state transition table. Here we see the Mealy machine transition table, which is divided in the two parts, the present state and next one is next state. And if we mapping the output function, a Q cross sigma gives delta. Let's see the Q naught state gives a 0 input alphabets and 0 input alphabets gives the output, and shown as input alphabet 1 gives the next state and gives the input alphabet output, which shown in the Mealy machine table. And now in the Moore machine table, which gives the state, next state, present state gives the states, number of states, and next state gives the input alphabets, that is 0 and 1. And finally, the output, which directly dependent on the state. Let's Moore machine transition table. A present state A, B, C, D, and the next state 0 and 1 input alphabets, and gives the output which is directly depend on the present state. Okay, thank you. Now let's start the topic on the next day. Thank you so much.